Hello, I'm the director of the Center of Decision Choice and Analysis, and I would like to tell you a few words about our center. We are we deal with a wide spectrum of decision-making problems. First of all, these are theoretical problems of multi- and unicriterial decisions, game-theoretic models, data analysis, social choice, even models in biology and medicine. And we apply all our knowledge to some urgent problems which influence all people around. I mean, on our planet. You see, indeed, we recently studied and developed models of decision making under deep uncertainty and apply them to food security problems, earthquakes, and tornado prediction, to ecology problems such as oil spills in Arctic waters. One of the last works which were presented one of our groups was efficiency of quarantine measures in pandemic situation of COVID-19, and we found very interesting solutions for this very problem. They were published. Another set of our studies deals with the political analysis. We provide some new models of polarization in societies and study its impact on electoral processes. But not only these problems of polarization, we have many other works in this field. We all recently very actively work on networks. We develop new concepts of centrality measure which take into account the parameters of vertices, influence of group of vertices on a single vertex, and also indirect influence on networks. And we apply these very new models, and many of them were published already, to migration processes, to conflicts among countries, world finance connections, different types of international trade, bibliometrics. We have also very new and very well deep models of multi-criterial decision making in social choice. We provided new models of solution concepts, analyze their stability. Another group of models deals with fuzzy sets and systems. Again, we extend existing models to this kind of things. We have several new models and some applied works in the analysis of education, and partly these very things which I'm talking about will be presented by next speakers from our group, from our center. Another very important part of our studies are regional problems. The main goal of these models to increase the satisfaction of people living in the region under study. When I spoke with governors of regions, and also we did it for some foreign cities, I told them that we don't know your problems. You see, we are living in Moscow, we cannot know all your problems, but these problems you observe in different places of the region. there are different ways to solve these problems, different financing to solve these problems. And so we obtain such complex problem of applying resources to solve these problems in different places on different levels, etc., that you need a very advanced mathematical models to solve these very problems. So I welcome you for some scientific contacts, and we will be very glad to work with the colleagues from different universities on this wide spectrum of problems. And these works might be presented as scientific cooperation, joint seminars, lectures, etc. In all these fields. Or we can invite young colleagues, for instance, to our PhD and master programs to come here for short visits, for a few months, for instance, to learn different kind of our models, our activities, etc. So welcome, and we are looking forward for efficient cooperation.
Hi, my name is Boris Mirkin. I work as a researcher in this center. And here I want to tell you a few words about my research. So I always do data analysis. I started with the group choice, social choice, but my approach was different. It was about rather individual data summarization than the behavioral aspects. Then I switched to clustering. And again, it is about data recovery from clustering rather than just looking in there. And currently, I'm doing several projects. One of them is consensus clustering, and the other is about community detection in networks with nodes attributed with features. Here are our publications with my PhD student, Soroush Shalele. And to me, the most important of them is modeling generalization in taxonomies. It's a kind of borders with cognitive aspects. And the applications include revealing tendencies over hundreds and thousands of publications on the subject, and also about expanding audiences of internet advertisements. Thank you.
My name is Ekaterina Shkhaliyeva, and I am a research assistant of the International Center of Analysis and Decision Making. I've been working as a research assistant for the past 2 years. During this time, I was in charge of a project about assessment of quality of higher education in Russia and analysis of its heterogeneity. The analysis revealed such unusual trends in mathematical areas of study as a quite low quality in economical specialties. And also, as a part of that study, we provided a new mathematical model for assessing admission to institutions. At the moment, I'm working on the development of a model for predicting the consequences of earthquakes in seismically active regions. Why do I like working in the center? Because here you have a large number of interesting and non-standard tasks, and you can always find a topic that is very close to you. And of course, you are always surrounded by bright, intelligent people who share your interest in science and will always help you when you need. At the same time, you always know that your work is valuable, and you can perform your work on the conferences that are international, and you know that your work will benefit the society. That also motivates you to work further in the center.
My name is Alexander Belenki. I am a leading research fellow at the center. Every scientific center in the field of technical and/or economic studies pretends to be unique in the way it deals with practical problems. The International Center of Decision Choice and Analysis is unique in its strategy of determining the area of its studies, not by attempting to adjust them to any practical problem, but rather by proceeding from the needs determined by these problems. One direction of research at the center covers problems associated with making decisions under uncertainty. The center studies in these directions are particularly focused on identifying classes of mathematical models for which effective solution methods in large-scale systems can be developed. Finding an optimal structure of a transport node, finding an optimal distribution of agricultural areas for growing products, finding optimal portfolio composition for small and medium price-taking traders are examples of the large-scale systems in which such models and methods have been obtained. Both these results and their underlying ideas have been published in top international scientific journals, including International Journal of Public Administration, Energy System, etc. These results are offered at the Higher School of Economics for bachelor and master graduates in the framework of the courses at the Faculty of Computer Sciences and the Faculty of Social Sciences. As is known, a game-theoretic approach is often used in modeling various conflict situations. So particular game models have been one of the subjects of studies at the center in the last 14 years. For two-person games, with the sets of feasible player strategies being convex polyhedral sets in finite dimensional spaces, and the pair function being the sum of two linear and a bilinear functions of the same vector arguments, the finite methods of finding Nash equilibrium points have been obtained. Besides the above-mentioned practical problems, these results were obtained for the problem of cleaning large cities by utilizing their municipal solid waste and for problem of optimally allocating charging stations for electric vehicles along highways. The latter one was published together with Princeton University. Another direction of research deals with education and the problem of choosing electives to study by a college or university student together with a set of core courses has been solved. A mathematical tool for comparing the set of electives that may look optimal to some students from the viewpoints of the college or university administration and the set of electives that may look optimal to a particular student himself or herself has been developed, namely a game-theoretic model and a discrete optimization model proposed to formalize both problems allow one to solve these problems by standard software packages. Finally, an educational technology developing analytical thinking in college or university students while providing them with particular knowledge of the subject of their curricula has been proposed. A mathematical model helping college or university administrations estimate financial aspects of the technology implementation, substantiate their financial needs in negotiation with potential sponsors, and compete for potential students has been proposed. This model helps calculate A, the maximum percentage of the student expected to succeed in studying each course under the fixed budget, and B, the minimal budget to secure achievable desirable percentages of the students expected to succeed in studying courses under this technology.
My name is Daniel Tkachov. I am a research assistant. I have worked at this center since 2020. At the first year of my work, I studied the measure of the balancedness of the Reichstag of the Weimar Republic. I have constructed models describing all possible coalitions in the Reichstag and evaluated the measure of the balancedness, which shows the degree of proximity to the total balanced parliament. The results of this work have been published at the Large-Scale Systems Control Journal. At the second year, I studied power indexes taking into account agents' preferences to coalesce. I have considered linear functions of intensity connections and introduced an axiomatization for them. The results of this work have been published as preprint of the working paper series, Mathematical Methods or Decision-Making in Economics, Business and Politics. Now, my research field is network analysis. In our team, we have created new models for identifying vulnerable countries to food consumption deficit in food networks using classical and new centrality indexes. The results of this work were published in Procedure Computer Science. Results of the research were also presented at the two international conferences, ITQM and MaxPro. At the end, I would like to say that my work brings me great pleasure. I spent a lot of effort on it, but I get a lot more enjoyment. I'm happy to work with and learn from great professionals in our team.
My name is Alexander Karpov. I am Senior Research Fellow at International Center of Decision, Choice and Analysis. My major research field is structured preferences. It is a field between economics and computer science. Nowadays, computational environment help us to solve many problems concerning aggregation of preferences. For example, recommender system, matching markers, etc. In many cases, unrestricted domain and preferences leads to computationally hard solution, and we cannot apply them quickly in online environment. So we need some information from structure of preferences, and if preferences share common structure or we have some interconnection between preferences, we can apply this information to solve preference aggregation problems. And the simplest example is single peak preferences. So we have an axis, so we have a space of left and right policies. We have a space, marketing space, so we have a brand which is close to Apple, brand which is close to Samsung, whatever. And all agents have ideal points on this axis, and all alternatives also belong to this axis. And all agents want to have as close as possible alternatives on this axis. So having this very simple structure of alternative space, we can design efficient algorithms, we can solve many real-life problems. Thank you.
I'm Stopachkina Anna and I'm research assistant. Our work is about network analysis on studies of Parkinson's disease. Millions of patients are suffering from Parkinson's disease, and this number is constantly growing. More than 5,000 papers are published annually on different aspects of the disease, so it's necessary to take into account major trends. Due to the large amount of data, it's necessary to use well-developed computational techniques. In our work, we apply network and citation analysis to evaluate the impact of certain papers, journals, authors, and their affiliations. We have collected and pre-processed information about more than 70,000 papers from almost 5,000 journals. and have computed several classical centrality indices as well as new ones introduced by Aleskerov and Yakuba in 2020. Those indices can take into account different parameters of the nodes.
I'm Ksenia Zinoveva. I am as well research assistant in the lab. So the main goal of our work is to develop a holistic methodology for analyzing a particular scientific field. It means that using our approach, we will be able to analyze every area of science in different aspects. First aspect is citation analysis. We analyze the pattern of how publications, organizations, authors, and journals cite each other. And the second aspect is the semantic similarity of the publications. Our area of work is the citation analysis. So comparing to existing methods, our approach allows us to take into account more sophisticated and more complex parameters of the network, of the citation network, not only the number of citations. And what is the outcome of our research to the scientific society? It could be helpful to understand the main tendencies and maybe even more helpful to understand and to extract the hidden groups of publications of journals and authors which intensively grow and cite each other very much. So it may be used, for example, for identifying an area or for profitable investment. And also it can be used to evaluate the impact of different journals and authors to the society.
Hello, my name is Alexey Mechon. I'm an associate professor in Department of Mathematics in National Research University, Higher School of Economics, and a senior research fellow in the International Center of Decision Choice and Analysis. I teach various disciplines related to mathematics and methods of decision making. My research focuses on data analysis, specifically pattern analysis. My students do different researches in, of course, using practical application of pattern analysis, some methods of machine learning, including clustering, classification, text mining, sentiment analysis. Thank you for your attention.
Hello, my name is Kobets Dmitry. I'm a stagiaire assistant in International Center of Decision Choice and Analysis, and I am a master student in public administration in Higher School of Economics. I modeling transport infrastructure in Kamchatka region and modeling different scenarios of volcanic hazards in this region. And I want to understand how we can, what we can do now for future for reduce consequence for this infrastructure, I think.
My name is Sergey Demin, and I'm Junior Research Fellow in the International Center of Decision and Choice and Analysis. In this International Center, we study different directions in the science of decision choice and decision making and decision analysis. And I will describe briefly about several directions wherein I'm working. The first one is a group of projects where we carried out new models of data development analysis. It is modern technology for efficiency evaluation of similar objects. And we have carried out several new methods in this topic. And afterwards, we applied our new models for different cases. And here are some of them. At first, we evaluated the efficiency of firefighting preventive measures in different regions of Russian Federation, because we understand that unfortunately forest fires is certain problem for the Russian Federation, and each summer there are huge territories under fire, especially in some Siberian regions and so on. And so we tried to evaluate and rank different regions according to efficiency of their firefighting strategy inside the region. The second case, we again applied our new modern methods of data development analysis for the efficiency evaluation of anti-coronavirus quarantine measures in different countries. We studied big countries with population over 10 million people, and we have constructed some time series of efficiency evaluation for these countries, and afterwards we divided all the countries into several groups with similar behavior of efficiency evaluation inside them. And one more interesting topic is so-called simulation processes. We constructed different iterational models, which helps us to simulate some dynamic processes. And here is the example of simulation of oil spills in the Arctic region. Using these models, we take into account many factors which influence the spill and the spread of this oil spill. And as a result, we can, in a few seconds, simulate the future process of potential oil spill in some specific circumstances, like Arctic region ecosystem.
My name is Anna Semina, and I'm a research assistant in the International Center of Decision Choice and Analysis. Basically, my job is to do some science. For example, together with my colleague and my friend Anastasia Kazachinskaya, we have conducted a study about international business journals from the Scopus database. This study was presented at the ITQM conference and published in Procedia Computer Science. So we have performed a bibliometric analysis of almost 1,500 journals related to the area of business management and accounting. Our main goal was to see if Scopus metrics, site score, SNP, and SGR are good at evaluating journals and if they have dependencies with other parameters. We have downloaded data from the Scopus database, processed it, and made some ratings. Finally, we have figured out that none of the metrics that I mentioned before have correlations with either number of citations or number of documents, which is a good sign. It means that these metrics are pretty weighted. However, citations and documents have pretty strong dependencies between themselves. Also, another part of our work was to analyze publishers and subcategories of the journals.
Now, you listened almost all of our colleagues and their activities, about their activities in different fields of decision analysis. And so I would like to repeat that we will be very glad to have some joint work, some cooperation with the colleagues from different universities in a very different form. For instance, we can give lectures for colleagues. We can invite young colleagues to our PhD and master programs. This might be joint seminars. We have 2 seminars, all Russian seminars on decision analysis, and we will be very glad to invite colleagues to present their papers on our seminars. And there might be other ways for our scientific cooperation. Thank you.